Welcome to qnawire.
So we have a cone of radius r and height h. So if we want to place this in the XYZ space, so we have here some cone and oh, it's upside down, so the base is on top. So if we have here and height h, and this distance here is r, you want to find the centroid. So we call this one x, y, and z uh, by symmetry about the rotations around theta in cylindrical coordinates. The average x is going to be equal to the average y, which is going to be 0. So we need to find uh, what is the average c. So that should be equal to, well, if we call this surface S, we would only be considering the lateral surface without the base. So we're only going around this surface of so this C bar would be equal to uh, 1 over the area of S, the area, and then the integral over S of C um, times the sigma. This is the differential of area, and then this region can be described as, well, x is equal to r cos theta, y is equal to r sin theta, and if we have here uh, some c and then r, we know that for c equals h, the, well, let's call this r naught there. So the distance on r should be equal to r naught. This distance there is r naught. So that well, at uh, this is the line. It's gonna be a line that has well, c divided by h times r naught, because, well, that is um, that should be r, so that, well, if you plug in c equals to h, you get the h cancels with the h, and then r is gonna be equal to r naught. But well, if we wanted to write c in terms of this, we would have that c is gonna be equal to r divided by r naught uh, times h. So the c coordinate for the surface is gonna be r over r naught times h. And so all this differential area is going to be equal to r theta cross product with r sub r times d r d theta. So this vector is that is the determinant of this matrix I, j, k. This vector there is that determinant. So here we have the derivatives of the components with respect to theta. So for x we would have derivative of x, that's going to be minus r sine of theta. For y, r cos, and then for c it would be 0, and the derivative with respect to r would be so r cos, r sine for theta, and for k is gonna be h over r naught. So that this vector is gonna have I component is gonna be r times h over r naught times cos. So this times that, and then j will be minus that times that, so plus r times h over r naught over r naught times sine of theta times j, and for the k component it would be r, so minus r sine squared, and r, so it would be r squared, and then r squared cos squared, and that over the k component, so that this vector is gonna have so we have this would be that square, so but this should be derivative with respect to r, so there shouldn't be an r there, so this comes out like r. So when we were computing this over here should be derivatives of the component with respect to r. So the derivative of this of x with respect to r would be just cosine of theta. Derivative of c, just sine. So that is correct there, and then that square would be h over r naught, all of that square, and that times cos squared. But for this comes out the same squared plus sine squared, and then for that it will be just well, this is 1, so plus r squared, and then well, this is 1, so it would be, we can factor the r square root of h over r naught square plus 1. So that is the differential. The norm of that vector is that, And so when we're doing that, when we're integrating C, we'll be integrating C is equal to R times H over R naught. We'll be integrating that. This is C, and then this from the differential R times the square root of H over R naught plus 1 dr d theta. So well, R goes from 0 up to H, no, up to R naught, up to R naught, and theta goes all the way around 0 to 2 pi. So this would be, well, the integral we're gonna be, this would be just constant, so H over R naught times the square root of H over R naught squared plus 1, and then we'll have the integral of R squared dr, which is R cubed thirds. So it will be all that evaluated between R naught and 0, so R naught cubed thirds, and then that times the integral from 0 up to 2 pi the theta, which all this is 2 pi, so that this would be well, we can, to simplify things, we can write this fraction as H squared plus R naught squared over R naught squared, so that if we have the square root of that, this is equal to the square root on top of the, and then this comes out R naught, so that this whole thing will be H times the square root of H squared plus R naught squared over, so R naught times R naught times R naught, and then times R naught to the third power divided by 3 times 2 pi. So this cancels 2 powers there, so this would be equal to 2 pi times H times R naught times the square root of H squared plus R naught squared thirds. So you have that, and then well, this was just that, but the area would be just integrating this without C. So the area is going to be equal to the integral from 0 to 2 pi from 0 to R naught of this, and of R times the square root of H over R naught squared plus 1 the R d theta. So that is the area, and then well, the integral of R dr is R squared halves, so all that evaluated there. So we can pull this out and then evaluate the integral so that it will be the square root of h squared, and well, that fraction is equal to h squared plus r naught squared over r naught squared, and then that times r naught squared halves, and then that times the integral from 0 to 2 pi d theta, which is equal to 2 pi, so that this is going to be equal to the h squared plus r naught squared, and then over r naught times r naught squared halves times 2 pi, so that this cancels and that also cancels, so it will be pi times r naught square root of h squared plus r naught squared. So that is the area, and then well, we need to divide this by the area. So the average value for C would be equal to this number, 2 pi times h times r naught times the square root of r naught squared plus h squared thirds, and all that divided by this pi times r naught square root of h squared plus r naught squared, but this number is equal to that number divided by 1, and divided into fractions is the same as this multiplied by that divided by this multiplied by that, so that becomes 2 pi h r naught the square root and then divided by 3 pi r naught times the square root. So very nice, this square roots cancel, r naught cancels, pi cancels, so that it should be equal to 2h thirds. So that will be the average value for C. But one thing to note is that well, that is if we place the cone like with the base on top, so the average C would be so we have 2h thirds, but with the base on top, so that with for a cone with base on top, which well, usually you draw a cone with the base on the bottom. So if you wanted to see what is the average C for this case, you would need to take this value that we have and so subtract H from that value that we have there. So 2/3, which, well, if you do that, would be H thirds. So if the base is on the bottom, it would be H thirds. In the other case, is 2H thirds.